President of the Institute, and I'd like to welcome all of you, including past presidents. I've seen a few of them joining us this evening. And we're already nearly 120 people, so there's obviously a lot of interest in the topic. What has brought this about is that the Northern Cape area has now reached its transmission capacity limit because of the amount of renewable energy projects that have been installed there over the last 7+ years. This means that although we have some of the best sunshine in the world, we cannot accommodate any more projects in the Northern Cape at the moment. So we'd like to hear from Eskom this evening what they intend to do to try and alleviate the problem. And to that effect, we'll first listen to Leslie Naidoo, who is the Senior Manager, Transmission Grid Planning at Eskom. And he'll talk about the transmission development process and assumptions that have been made, the grid challenges, and he'll talk about new grid infrastructure that is being built and what risks and challenges there are to the TDP. Followed by that, Zizo Mkhize, who's also in the same department, will talk about measures that Eskom is currently taking to expedite the transmission development plan. And then in summary, we'll have Ronald Murray talking about the latest renewable energy grid survey results. So it's my pleasure to first of all introduce Leslie Naidoo to you all. Leslie has a BEng and an MSc in engineering and a diploma in datamatics. He's worked for Eskom for 29 years, primarily in transmission, and he's been there in a role as the grid planning manager. And he also has some software programming experience, and he's represented Eskom Transmission at the Southern African Power Pool. Furthermore, he's a registered professional engineer with EXA, and he's a member of the Institute. So Leslie, welcome, and we look forward to listening to you and your team this evening. So when you're finished, I'll also introduce Zizo, and after that, Ronald.
The President of the Institute, Prof. de Kock, thank you very much. Members of the SAIEE and distinguished guests. As indicated, my role today is to take you through a fairly high level of the transmission development plan. Generally, we publish this on an annual basis. It's normally a 3.5, close to 4-hour session, but we tried to compress it to give you this, the pertinent facts, and then we'll go into the details during question. If I can get an heads up, can you see my presentation?
Yes, Leslie, I can see it from the side.
All right, I just want to switch off my camera. Right, I'm going to put it onto Zoom, and then we are off to go. Thank you very much. So I will be taking you through the background of the TDP at a fairly high level, focusing on the assumptions, the challenges we face, and the developments across the country to meet the assumptions that we have taken. Now, just to give you the background, the TDP as part, it's actually a requirement from the transmission license as stipulated by the regulator through the grid code, where it says that the National Transmission Company shall annually publish a minimum 5-year transmission development plan. And over the past 10 years or so, I think the first TDP we published was in 2010, and we've been publishing a 10-year program indicating the major capital investment plans, but not necessarily approved. Now, in coming up with the planning for the transmission system, this is not an Eskom plan. This is a country plan for the interconnected power system. And it's based on a consultative process. And you can see the details that we go through, understanding the requirements from the demand for the country, engagements with the distributors, large customers, redistributors, also the generators, incorporating mainly now more so the independent power producers to get a gauge and understanding in terms of their future plans and aspirations, jointly with the various associations, and here I'm specifically referring to the renewable energy associations, so that we can understand their plans and to ensure that the development of the transmission system aligns with the future requirements of the country as well. And it's just not about planning the electrical transmission network. It's also engaging with the OEMs, suppliers, manufacturers, construction industry to ensure that the plans that we come up with can be implemented, and making sure that the necessary capacity across the industry is ready to meet the requirements of this plan. Also, of equal importance is investors, because as I will show you later on, that to roll out this plan requires a significant amount of capital investments, and more so our state-owned companies, our partners in government, the regulator, the various ministries, to ensure that there's alignment from a policy and from a country perspective.
Leslie, we can't hear you at the moment. You're muted as well.
Okay, somebody has muted me. Sorry about that. All right, not much, but this quick feedback is that the TDP, as I indicate, as can be seen, is a transmission license requirement from the regulator, and we need to do this on an annual basis. And it's a consultative process involving lots of stakeholders across the electricity supply industry, as well as our shareholders in government, stakeholders in government, I should say, the various departments, to ensure that the plans that we come up aligns to policy and meets the aspiration of our customers, being it the distributors, redistributors, large industrial customers connected onto the system from a demand perspective, as well as to meet the anticipated new generation requirements for the country. Now, the key focus or objective of the TDP is to ensure that the interconnected power system meets the minimum grid code compliance requirements from a reliability perspective in terms of adequacy and security of supply. Likewise, determining the new network infrastructure requirements to sustain and allow for future demand growth, as well as what is more topical today, to meet the new network infrastructure requirements to integrate new generation capacity, as indicated in the Integrated Resource Plan of 2019. Likewise, the Eskom corporate strategy requirements and other programs from the private sector participation, especially in the renewable energy space. Now, when we look at the assumptions, from a demand perspective, and we do this on an annual basis, we have a load forecasting section or area in our department that engages with various stakeholders to understand what is the future demand pattern for the country. Suffice to say, in the coming 10-year horizon, due to various factors, as indicated on your right side of the screen, we have adopted a very moderate forecast for obvious reasons. And in the 10-year horizon up to 2032, we are looking at about an increase from our current peak or last year's peak of around 34 gigawatts up to around 43 gigawatts of demand. Fairly consistent, fairly moderate, nothing unusual. And just to give you a sense as to what's driving demand, we use various sources of information, mainly applications that we process to customers, be it a budget quote, which is provides more certainty in terms of where the growth is coming from. Then there's indicative cost estimate letters that we issue to interested customers or for connection onto the system, as well as market intelligence. Suffice to say, what we are seeing is various areas, especially in Gauteng and in the Western Cape and elsewhere, there's a huge drive towards data centers that are coming up, and these data centers consume a substantial amount of power. Over and above the data centers, I think in the Northern Cape, we've got the mining activities as well as in Limpopo and elsewhere in the country. So we've got a good sense of what the demand for the country, and more so in terms of location as to where they will come up. And the good thing about this, these things don't happen overnight. So we work in close conjunction with the customers to get a good sense in terms of the timing and to make sure that our networks are in place to meet that requirement. However, our challenge going forward, as you can see here, in the period of the TDP 23 to 2032, this is the challenge that we as transmission and the country faces. Based on our assumptions, we're looking at 53 gigawatts of new generation capacity that's planned for the country. A lot of it in green that indicates wind, just over 21 gigawatts of wind we anticipate, over 14,000 gigawatts of solar, as well as a significant amount of storage, just over 6,500 megawatts. And then there's gas, just under 4 gigs, and in 2,500 hydro. Now, the question is, what's driving that? Because if you look at the IRP, which I will talk about I think it's in the coming slides, projected around 30 gigawatts of new generation capacity by 2030. However, the IRP was based on an energy availability factor from Eskom in the vicinity of around 75%. However, as most of us are aware, that has significantly dropped in the recent past. And I think we're currently sitting at about 60%. What this means is
someone's muted Leslie again.
Can you hear me now? I think for some reason I'm being muted. Sorry about that.
Yes, we can hear you now, Leslie.
All right. Sorry, my apologies, but I'm not too sure why. All right. I hope I'm back. Right. Now, the challenge that we face is we know we need this quantum of new renewables. The question is where? And then how do we get that information? What we do is we gather various sources of information, first and foremost, to identify the location. We use the solar maps for the country to give us a good indication of where the solar irradiation and irradiation factors are. We look at the wind map, also where the gas potential, and I think coal, we get a good understanding. knowing where the sun is shining or where the wind blowing is not good, is not enough. We also need to understand the environmental constraints, the sensitive areas, the no-go zones. So we gather that information, superimpose it onto the map, and then we get the positive areas, if I could put it that way. And you can see the pockets. As much as you've got large quantities of solar on a large vicinity of the country, but if you superimpose the sensitive areas, you can see, yes, still there's a huge potential for solar in the Northern Cape, bits on the Eastern Cape, as well as inland. When you come to wind, you can see mainly the corridor coming down towards the Cape, Eastern Cape, and bits of the Northern Cape. So this gives you a sense of, after you've factored in the sensitive areas, where's the potential for viable resources, be it solar or wind, or gas for that matter. Then in choosing where the networks are and how we bring this together, we also use information from the CSIR wind and solar resource maps. We look at the applications that are being processed by the Department of Forestry, Fisheries and Environment, previously known as DFE, and that in conjunction with the applications that we have processed, both ourselves as well as applications for EIA. So that gives us a good sense of where people or developers are proposing their plants. This is also followed by looking at the solar sites in terms of the lowest cost yield, both for solar and wind, and looking at the economics of that, and understanding from the surveys that we do. And then we look at the network analysis from performing the power systems analysis to see what capability or capacity we have on the grid to accommodate the new resources that are required. And ultimately, we allocate, you can see in the map in the bottom, we allocate the generation from the various resources. The green circles indicate the wind, and the yellow in terms of where the solar potential are. And then we look at the networks to see what new capacity will be required, new infrastructure would be required if this generation is to materialize. Now, having done all of that, we also do a survey with the industry, and here we're talking about the renewable energy industry, to make sure that the assumptions that we use, that there is collaboration. So if you look at the interest, and this was the survey that was done in 2022, the first quarter. My colleague Ronald will talk about the latest survey that was done last month in the latter part of the presentations. And you can see where the applications came from, or where the interest lies for both wind and solar, solar in yellow and wind in green. And this gives us a good indication in terms of the alignment of our plans with that of the market intelligence, if I could put it that way. And then you can see for coal, likewise, in the Mpumalanga and sort of northern province of the country. So what we have realized, or what we have picked up, is that there's a strong correlation with the information that we have processed from the applications that we have got, as well as from the industry in terms of the interest in those specific areas. So now comes our challenge. We know for a fact, as you have indicated, Prof, early on, that a large portion of our country, especially in the broader Cape areas, has run out of network capacity. And that is the area that has got the most amount of interest from the industry, specifically when it comes to solar as well as wind. Now, we need to connect in the coming 10-year horizon 53 gigawatts of new generation onto the system to meet the country's aspirations. We also have to address the current reliability requirements of the network, and this is going to require a significant amount of investments in transmission infrastructure by building new transmission lines and substations in this coming 10-year horizons, or 10-year horizon. On the positive side, at least the budget for the coming 5 years for this capital requirements, we have managed to secure from our corporate finance area. The challenge, however, is for this large amount of new infrastructure that is required, it was never done before. And looking at the typical timelines to build transmission infrastructure taking up to 8 to 10 years, mainly associated with the time span for acquiring servitudes, places a huge strain on the build program, as well as the resource capacity in the country across the engineering, procurement, and construction value chain, and more so the capital requirements in the latter part of the period that is probably going to place a huge strain on the Eskom balance sheet. Now, if you look at this picture, the graph on your top left-hand side gives you an indication of what was the planned decommissioning of our coal fleet as indicated in the IRP. And as I spoke about earlier on, the IRP was based on an energy availability factor of around 75%. And that has decreased now to around 60%. So this picture has gotten worse. So currently we're sitting about, looking at the current plan, we are looking at about almost 15 gigs of our baseload power station will be decommissioned by 2032. Now, if you just think about it, if you are going to replace 1 megawatt of baseload by renewables with a capacity factor of around 30%, as an example, for every megawatt that you're going to need to replace, you're going to require 3 megawatts of a sort of renewable energy. So if you're planning to decommission 10 gigawatts of baseload with renewables, you've got to multiply that by 3. So that's where you're going to replace that by 30 gigawatts. So this places a huge challenge to the power system in terms of how do you bring this huge amount of intermittent renewable energy within the short space of time. So what does this mean for the transmission network? From a load perspective, as I said, we're looking at a very moderate load increase. Fortunately, the bulk of our demand is in the northern parts of the country, with 78% in the northern provinces. That's Gauteng, KwaZulu-Natal, Northwest, Mpumalanga, and Limpopo. And 22% of the demand is in the southern parts of the country. And we don't see this changing into the future. Just to give you a sense that Gauteng, the smallest province, is just consumes about, or makes up around just less than 30% of the demand. I think it's around 28% of the demand for the country. However, if you look at generation, it's a total different picture. The current generation in the country, in the vicinity of 72%, is in the north, mainly in Mpumalanga and Limpopo, and the remaining 28% or thereabout is 25% in the southern parts of the country. But based on our future predictions and assumptions, this is going to see a significant shift. There's going to be a huge decrease in the north, down to 48%, and a huge increase from the south, 52%, mainly coming from the renewable space and maybe gas on the coastlines. Now, our current architecture of the network or the transmission system is to shift power from the north to the south. Going forward, you're going to see a reversal of power, meaning that the bulk of the power that's generated in the south, unfortunately, because of the low demand, means that we need to shift this power to the load centers in the northern parts of the country. And if you look at this map out here, you can see the weak networks by single lines, specifically in the Northern Cape, as well as in the broader Cape, that's the Eastern and Western Cape regions. So herein lies our challenge. How quick can we get the networks into these areas so that we can meet the requirements by dispatching the power from the south towards the north? So doing the analysis and when we done the detailed power system studies, This just gives you a sense of the challenge we face in order to bring on board new infrastructure. So what I've tried to do is, on one map for the country, is to superimpose all the developments works. So just to give you an highlight, in the green rectangles, gives you a sense of the projects that are in execution. Typically, with the one on the top, Medupi, we are currently almost completed the transmission integration, networks integration, so that the power station can come online. I think it's the last unit that needs to be energized or commissioned. Likewise, at Kusile, and networks down into KwaZulu-Natal, the 765 kV line from Mfolozi down to Mpangeni, and the other projects in execution. Also, we see a large number of projects that are still in development, specifically across the country. In development, I mean that to a large extent, we have managed to secure or we've concluded on the environmental impact assessments, and we're finalizing the detailed designs so that these projects can move into execution. Our challenge is the projects that are still in the concept phase, identified in the gray rectangles. And you can see a lot of these projects are in the areas in the southern parts of the country that's desperately needed to realize the integration of the renewable energy. The dashed pink lines gives you an indication of the 765 kV corridors that will be required, as well as the green dashed line gives you an indication highlighting the new 400 kV lines. So a substantial amount of work, especially for the projects in concept phase, meaning that we are still in the process of acquiring servitudes. And once we've acquired the servitudes, then we can take it into detailed engineering and then followed by the execution. So we know that this is going to take time. Typically, to acquire servitudes could be anything between 5 years or even up to 7 or 8 years. And once we secured servitudes, then we can start construction. So what do we do in the interim period while we are still focusing on getting these projects into execution? Now, as much as we know that there's the resource for solar in the Northern Cape, wind in the Western Eastern Cape areas, we have run out of capacity. There are elsewhere on the network available capacity. Now, as much in the Northern Cape, following bid window 5 and 6, we have actually ran out of network capacity. By that I mean the transfer limits out of the Northern Cape have been exhausted. We have be it a thermal constraint or where it's a substation transformation constraint. So meaning that we can, there's a limited amount of transmission networks to evacuate or dispatch that power to the load centers elsewhere in the country. What compounds that problem is that demand in the Northern Cape is also fairly low, and you got excess generation, so that you need to, and that's where you need to rely on the transmission network to take the power to the load centers across the country. So we've done an analysis elsewhere on the network, and we looked at where can we maximize available network capacity, be it existing substations by adding additional transformers to bring on board new generation resources. And by doing that analysis, we looked at, in the quickest possible time, plus minus 3 to 4 years, or by 2027, we've analyzed the network, and we realized that we can bring on board an additional 12 gigawatts of generation capacity, mainly in the Free State, Northwest Province, and Mpumalanga, that has got existing capacity. It's got strong networks, but by adding additional transformers, we can get on board additional renewable energy into the system. Yes, it may not have the same capacity factor as the abundant solar in the Northern Cape, but yet it could give us the capacity that we need so desperately for the country. Suffice to say, after bid window 6, the capacity in the Northern, Western, and Eastern Cape have been taken up as well. So we have run out of that capacity in the southern parts of the country. Overall summary, if you look at the infrastructure that we are looking at, in the coming 10-year horizon, just over 14,000 kilometers of lines, a substantial amount of 765 kV lines, just over 6,000 kilometers, followed by the 400 kV networks. And of significant importance is also the transformations. These expedited or additional transformers I spoke about, we are looking at bringing on board 170, or we would require 170 transformers in this 10-year horizon. Likewise, the number of capacitors and reactors. So this is going to pose a huge challenge to the build industry or the infrastructure build industry in the country. And my colleague Zizo will take us through the details of that in the next presentation. But just to give you a sense, while we know that this is a huge challenge, it's the first time we're going through this, our focus from a transmission perspective, while we are sorting servitudes, EIAs, CapEx in the latter parts of the TDP period, our focus is in the coming 5-year horizon. Put things into context. If you look at the last 10 years, we've managed to build 4,300 odd kilometers of lines. In the coming 10-year horizon, we're looking at 14,200 kilometers. So on average, if you translate this, that's about just close to 4,430 kilometers of lines. And now we need to shift this up to 1,400, a 325% increase. And if you look at 14,200 kilometers of lines, when compared to our existing network of around 33,000, you're looking at a 43% increase in the circuits that we would require. A similar picture emerges for the transformers from just over 19,000 MVA to over 122,000 MVA that will be required, indicating a 600% increase in the in that infrastructure, which comes to about an addition of 77% onto our existing network. And this large percentage of, or a significant amount of this is to do with the 170 transformers that I indicated. And if you look at the past 10 years or so, I think we managed to bring on board just over 30 somewhat transformers. So there's a significant volumetric increase in the bulk capacity for the transmission system going forward. So our challenges is that the network constraints, especially in the Northern, Western, and Eastern Cape regions, requires significant network augmentation, mainly in terms of 765 kV corridors, both on the Northern, Central, as well as between the Eastern Cape and KwaZulu-Natal. CapEx requirements, specifically towards the latter parts of the TDP period, are going to be a huge challenge onto the Eskom balance sheet. And our major risk in terms still resides with implementing the TDP. I think we have done the plans. We know what is required. Our challenge is in terms of the time it takes to acquire servitudes, the resource constraints in the country across the engineering, procurement, and construction value chain to execute this plan. Chair, on that note, I can take questions or we can move to the next presentation.
Thank you, Leslie. I think let's first of all complete the presentations and then we'll take questions afterwards.
Thank you.
So, ladies and gentlemen, we'll now move on to the second presentation by Zozo Mkhize. She holds a BSc, a BTech, MSc in electrical engineering or in civil engineering. She's has more than 20 years experience, and currently she also works in the transmission development department. She will focus her presentation on measures and initiatives to expedite the implementation of the TDP. Zizu, over to you.
Thank you, Chairperson, and good evening, ladies and gentlemen. Let me share my presentation. Thank you. So as said, I will be presenting the initiatives that are there to deliver the TDP. And my presentation, it has what sort of structures that we have in place to support the TDP and the TDP readiness index and the owner's engineer and the EPC, and what are the short-term and the medium strategies that we have in place. And then as well, it will deal, excuse me, Chairperson, I think I'm sharing the an old presentation. I need to just change it quickly. Thank you. Yes, and then also the enablers in terms of what we have in place for the TDP. Leslie has presented earlier on, and he spoke about the 14,218 kilometers that is required for the TDP 2022. If you look in terms of the history or the past 10 years for Eskom, we have done 4,247. So in principle, we are looking in terms of what is it that we can do then to be able to deliver the required kilometers. And same in terms of the GVAs for our transformers in the substation, that is the increase that you see there. So in transmission, we have set and looked into the requirements that are in place, and then we have put up the strategies to have the step change performance that is required to deliver the infrastructure. And we have internal and external forums or strategic meetings that are in place to ensure that those decisions are done and also at a pace that will support the delivery that is needed. Out of that, we have what we called the streams, and the streams are to report on each of those milestones that are allocated to them. And we have 9 of those, and I will take you through on the other slide that has got your TDP readiness index. So in terms of the support with the government, we have Energy Nut Joint Workstream 10, and this has just been recently established. We were previously a part of the Energy Nut Joint Workstream 2, but due to the forecast that is needed for transmission, then this workstream was set up. So this workstream is being shared by our GE, and the co-chair is the industry support, which is Ms. Erica Johnson. And the objectives in there are we deal with the expansion and the stability of the grid capacity. What is it that Eskom needs in terms of the support to expedite the regulatory approvals? That being your EIAs, and sometimes in terms of the land that we require, as Leslie has mentioned earlier on, that one of the challenges that Eskom has got is to have the servitudes in place for us to build and deliver the required infrastructure. And in this particular meeting, then we sit with the DFFEs, the DPWIs, and then they check in terms of what is it that Eskom requires for support. And then also we look in terms of the regional interconnectors and also for the funding. And of course, there are ad hoc projects that come to be presented in the Nut Joint itself, like your bid window 7 progress, the best progress, all of those, because they are all for integration purpose to be able to deliver what is required for the infrastructure. So in terms of the priorities that we have in place, priority initiatives that we have in place, we looked into the TDP 2022 that was published last year. And from there, we have the resource planning inside one of the departments that look in terms of what is it in for resources internally and resources externally to deliver the TDP. And one of the decisions that was taken by one of the structures within Eskom was that 40% of the numbers that you see for TDP will be done using the owner's engineer or the EPC contracting methodology. And currently we do have our commodity contracts, which include your transformers, your insulators, the conductors, at 97%. So all of those are also being tracked in the structures within Eskom to ensure that all the material that is required and the one that will be supplied by Eskom is in place for the TDP. And then also one of the achievements that we've had, it's regarding the environmental approvals, your EIAs. Previously, we were taking about 107 days with DFFE, but that has really reduced it to 57 days. And while that has been reduced, where possible via the nut joints that I've explained earlier on, they see again what is it that they can do to support Eskom and reduce those days from 57 to any other number that is less than that, depending, of course, on the complexity of the submission that we've made. And another successful thing that has happened last year, it was regarding the expropriation of land that was approved by the minister for 24 land parcels. And these projects have been delayed because of the issues that Eskom couldn't get the consent to occupy, meaning that we're not able to even finalize the design and appoint the contractors to do the work. But once that has been done, now we are able to continue on the projects that the expropriation has happened on. And now we are busy with the phase 2 that we are submitting to government, also that to support Eskom for the expropriation. And then I've already mentioned in terms of the government, how we're working with them to ensure the successful delivery of the program. We've looked also, as I've mentioned, resource planning. Resource planning, they also looked into the commodities, what support we need and where they identify the gaps versus the TDP 2022. So in terms of the transformers, there are 20 factories that Eskom has looked into and they've been accredited for class 3B. And if you also a person that is working on the transformer industry, you have seen that we have 101 transformers that have been issued to the market. And previously, Eskom would only issue a number of transformers, maybe 10 or 15, or will issue a panel contract where later on will withdraw those transformers. But one of the initiatives now was to look in terms of the TDP and how many transformers that will be needed. And the 101 was issued to the market and it's closing in July 2023. Coming to the resources in terms of the construction services. Last year as well, there was a tender that was out in terms of the contractor incubation, and that process has been finalized, and the suppliers that were identified, they have started the courses that have been put in place for them, and this will assist to increase the number of suppliers that can build the transmission lines. And the intake, of course, will be done annually. And then one other thing we've done, TDP, looking at it with the kilometers of about 14,000 that is spoken about, those currently have come to about 847 projects. And then we said, how can we be able to have a view that will take us from cradle to the grave to see what is happening in the whole program? And we've decided to move from using MS projects, but go and use the P6 Primavera, where all the schedules are put into one place and we have the integrated view. And then while we are doing that, we've also integrated Primavera with the BI tool so that we can do the analytics. At any given point in time, you should be able to see the status of the project. If, let's say, you want to see how many megawatts that will be coming from the transformer project that Leslie was talking about earlier on, we are able to see that. And it also helps us to manage, to monitor and give the oversight into the program as a whole. And then the budgets have been approved and allocated for the 5-year program of the TDP. And one of the initiatives that we are having, actually 3 of them, we've got the owner's engineer. The owner's engineer, it was issued to the market. It closed in April, and we are still busy with the evaluation, and the planned date for award is October 2023. Now, in terms of the EPC itself, we've broken it down into 2. We've got the EPC for lines, which has been issued to the market. It was supposed to close in July last week, but an extension has been granted. Now it's going to close on the 7th of August. And then the substation one, we're still busy internally. It's going to the governance structures for approval. So that one will be issued, we are planning to issue it here in July with the award date of April 2024. And then looking in terms of the PLCM, we are managing where it starts in terms of the user requirement reports. And those we've got 94% that is in place for the next 3 years and 50% for the next 5 years. We manage where it starts, the PLCM, so that we are able to have enough projects that go through the process, so that when the owners, engineers have been appointed, the projects are in place. And also when we have the EPCs, the projects are there. So in terms of the EPC, again, we have done that identification of 40% in terms of which projects that would be executed in EPC and also in owner's engineer. I've spoken about the streams that we have that are in place in terms of managing the projects or the program itself, so that we can have the step change that is required in terms of performance. So if you look at it, we measure it for each and every month, and we have targets that have been put in place for each of the stream as to what is it that they need to deliver this year, so that we can have the readiness that we are requiring for the TDP delivery. So if you look at it, we've got, for example, execution sitting at 41%, and it's the lowest, mostly because of the extensions that were granted to the market for the owner's engineer one and also for the EPC. Hence, it is a small percentage. Should the owner's engineer be finalized and also the closure of the EPC and we start evaluation, then that one will automatically go up. And then network planning, I've already spoken about it. And then the PMO, that what we measure mostly is what I was talking about in terms of the P6 that is in place. And also, of course, the reports that they have to do and to ensure that there is visibility for the TDP. So currently we're sitting at 67%. And as I've explained, the movement was only into 2 streams for the month of June. So this slide, it just explains the difference and the scope that Eskom has in place for the owner's engineer versus the EPC. So owner's engineer is like an extension in terms of our internal resources for your engineering. They will be working hand in hand with our departments, project development, engineering, land and rights. They will do the survey, the geotechnical studies, all the statutory approvals that I was mentioning earlier on, and the basic design, and of course, project management. And they will also assist with the drafting of the procurement processes, all the documents that are needed. Should we be appointing the EPC or if we are going the traditional route? And also the contract management side of it, they will be involved. And so that's the owner's engineer. And then the EPC, we're gonna start from the detailed engineering design, and then the project management, procurement, construction, and project management until the commissioning or handover of the asset to Eskom. So this is the scope that is there. And there was a forum in Eskom on the 30th of May where a discussion was around EPC in detail. What is it that Eskom is requiring? And the project list was also shared in that forum. And then this week on the 13th and the 14th, there is another supplier forum. And in there, Eskom is gonna now address all the issues or part of the issues that came up from the previous forum, like the questions people were asking in terms of the contracting methodology. Why did we choose that? And also the scope. What is it that Eskom is expecting on the documents that were shared or they were issued into tender? So our colleagues from technical, they will be going through the tender requirements on the technical specification, and procurement will be going through the procurement requirements that were put on this tender. And that is for this week, which is Thursday and Fridays. I've spoken about the short-term to medium strategies that are in place to unlock the grid. Leslie mentioned the 12 gigawatts that has been identified as additional transformers across the country on the existing substations. These transformers will unlock the 13 gigawatts. Leslie said 12, and I'm saying 13 mostly because the number that you see here, it includes the IPP projects, and the one that had it exclude those ones. And these 25 accelerated transformer projects, they are being managed on the CAPEX delivery forum that is shared by the GE internally, and also we report on them on the progress to the workstream 10. Same with the 22 expedited projects that gives 24 gigawatts. So in total, it's about 37 gigawatts that is being managed to ensure that it's being available to the grid. And this is the short-term to medium strategies that we have. So if you look in terms of these projects that I'm mentioning, which is the transformer and the expedited projects, the transformer projects, even though there are 25, but the number of transformers that are in there, they are 37 in total. So this map, what it shows is for which province, how many megawatts will be enabled. So if you go to the Northern Cape, for example, you will see that it's gonna enable 6,339. And as well, on the legend itself, it shows as to which years. So where you see the blue, it's 2027, those megawatts will be enabled or will be commissioned, this project will be commissioned in 2027. And then where is green, it's 2030. So the bars themselves, they represent the years as to when these megawatts will be commissioned, and then on which province, of course. And the total number of projects is 47. This slide shows the corridor projects or expedited projects that are at 24 gigawatts. And then also, if you see here, it's Northern Cape, that is 5,845. And then, as you can see, of course, again, those ones are the years as to when those projects will be commissioned. Same with the transformer projects, and the 13 gigawatts that I was talking about. This is the plan that we have in Eskom as to when we're gonna commission this project. And then for the external support that we require, or the enablers that we require for us to be able to deliver the TDP 2022, DAFFE, I've already mentioned that they have reduced their days that they were taking previously in terms of the approvals of the EIA, but we do require continuous support because sometimes there are appeals even though we have those EIAs done and completed. So we need them to further help us to manage that process so that we are able to start the construction on the project. The expropriation DPWI is also assisting, and they are also part of the NAT Joint Work Stream 10, and we are working with them to fast track this process. And then there is a structure that has been set in the Eastern Cape for support. So we are also going to those structures and present as to what support Eskom is needing, especially for the government-owned land and also the access to the tribal-owned land. And then the market capacity, it's one of the things that we put as a challenge or as a risk sort of in terms of the delivery, because we do need the market to be ready to be able to manufacture the required commodities, and also for the construction contractors to be available when needed. Hence, we had that session that I'm mentioning on the 30th of May, where we presented in terms of what is the capacity that we might need in terms of commodities. And also we do have community disruptions when the projects are being constructed. And that's one of the support that we have also put forward to the NAT joints as to how can we minimize these community disruptions, because they are delaying the commissioning of the project. This is the last slide. Thanks, Chair.
Thank you very much, Zizu. There have been quite a number of questions already in the chat. I see Leslie has attempted to answer some of them. So thank you, Leslie. We'll now move over to the last presentation. This will be done by Ronald Murray, and he will talk to the most recent renewable energy grid survey. So Ronald has worked in the power industry for the last 29 years. He graduated from Wits and Tshwane Universities of Technology. He's registered with EXA as a professional technologist, and he's very much focused on the strategic grid planning in South Africa. Ronald also contributes to various SAIEE working groups. Ronald, we look forward to hearing from you what is happening in terms of the pressures from the renewable energy sector on the transmission system.
Okay, great. Thank you very much. I'm first want to show you just where you can get this presentation so that you can see. On the Eskom website, you can go to divisions, transmission. Yeah, you can get the development plans, but at the bottom here, you'll see the survey. If you click on the survey, you can get hard copies.
Leslie, Ronald, just share your screen.
All right, let's have a look. They're not sharing. Okay, let's try. There we go. Can you see it now?
Yes, we can.
Okay, let's go back here. So on the Eskom website, you go to Eskom divisions, transmission, the development plan, and all the other reports. So yeah, at the bottom, you'll get the survey. Yeah, you'll find hard copies of it that you can download. And yeah,
I think you're muted, Ronald.
sorry, I don't know why it's been mute. Okay, thanks. What's that? So this renewable survey is done on an annual basis, and it's done with the renewable associations. It's a forward-looking survey. So the contracted values is the amount that the IPPs would like to contract onto the grid. It's about 66 gigawatts, and the installed value is what would be installed on that site. So if you had PV and wind, PV and batteries, you would have more installed than what you'd need to evacuate out of the system. So there are various categories that we had to look at. with quite a significant amount of contributors from the renewable associations as well as outside of the associations. Wind, there's about 21 gigawatts, and generally the installed is very close to the contracted amount. In batteries and PV, you can see it's almost double what they want to install behind the meter. And with PV, some marginal over installation of PV onto the local site. And even wind and batteries, you can see almost doubling of the capacity. So the installed values can also be seen over here in detail compared to what they want to have the contracted amount. In terms of the technology overview, it can be split down into the various categories of plant per year, and you can then have a look at what is the phasing of it over time and what is the amount that has been installed. And if you want to look at the phasing of the PV and battery, you can have a look at how many batteries are intended to come in which particular year and what volumes is required. So overall, the large penetration of wind, followed by PV and batteries within the areas. We also were interested in to find out the status of the project. So we had 3 different categories of the project. Type A was projects that are ready to go, and we were requested records of decisions of the environmental EIAs and various other criteria, as you will see here. Type B were projects that we didn't require the actual number that you got your record of decision, but you need to indicate that you've submitted your reports and are waiting for your final decision, so you're very near ready. And the third category, type C, was projects under development, your intentions of where you'd like to get capacity in the next 5 to 7 years. So if we have a look at this, these are the 3 categories. So there's about 18 gigawatts of ready projects, 21 gigawatts of very near ready, and about 27 gigawatts under development. If you look at the projects that are ready, the colors that you can see, just for clarity, is the light yellow is PV on its own, the orange is PV and battery, the light green is wind on its own, and the dark green is wind and battery. So you can see that there's about 3 gigawatts of wind on its own, with about 2 gigawatts with wind and battery, and there's about 5.7 gigawatts of PV, and with PV and batteries another 5.5 gigawatts. So quite a significant amount of spread amongst the technologies, and all targeted very close to 2025. Although when we had a look at this data, these dates were very much December 2025, so we expect some slippage into 2026 as well. And the near ready, closer to 2026, large amount of PV is dominant with a reduced amount of wind. And then in the type C, a lot of development in the wind projects going forward. The categories of readiness, we had a look at spatially plotting them, as well as having a look at a timeline. And we can see that the build-up of the projects which are in red are the ready ones. The orangey color is the near ready, and these are the future projects. So a very good profile of projects across the years are being developed. If we look at the projects in category A, these are the 18 gigawatts, and a large amount of these are spread in the Cape area as well. There's near ready ones which are constrained in the Northern Cape, and then a lot of near ready ones in the Northwest. The near ready, I'll just overlap these together. You can see still within these dominant areas and still developing in these areas. But when we have a look at the new developments, we can see an increased growing out into Mpumalanga, the northern part of KZN, and spreading still in these common development areas. If we ask them then, which programs are you interested in? And the vast majority of them are interested in the DMRE projects, and then also looking at private off-takers. Very few are looking for just private off-takers on their own, and they're very concentrated in specific areas. Very few Munich off-takes, so we really have this dominant penetration looking for both DMRE and private sector. The clustering then is that we had a look at the projects in terms of the GCCA areas of interest. And if we have a look at the projects that are currently ready, we see that the upper numbers here are megawatts and the lower numbers are interested numbers of parties that are at each of these areas. You can see the dominant interest is the Western Cape, Northern Cape and Northwest, then spread into the Free State and Eastern Cape. These are the dominant areas. We had one applicant put a gas project in KZN, but in terms of the renewables, near-ready projects in these areas are very low. If we look at type B projects, you'll see it's still dominantly in the Western Cape, the Northern Cape, a lot of batteries you can see coming with the solar, as well as some independent battery projects. So the developers want to unlock their projects by moving their energy into unconstrained windows within the Northern Cape. A lot still in the Northwest, and the Northwest is really a solar dominant area. And then in the future, we see a big change where now you can see some projects coming into Mpumalanga, and a very big change is in KZN. So we see a lot of wind penetrating in the north of KZN, with still interest in the historical popular places. So if we look at EIA readiness, I won't spend too much time on this, but we can see that in 2023, there's just a handful of ready EIAs with 2024, and then the majority of these come in post 2026. When we look at the megawatts, this has a look at the spread of where the projects are. And if we look at the type A projects, so these are the projects that are ready, and we look just at the wind projects, we'll see that the wind projects are really constrained to very specific areas. So the projects that are ready are really locked into the Western Cape and the Eastern Cape, with very few outside of these areas. And if we add the wind with batteries even, we'll see that they're locked into these areas. And even if we add type B projects, we'll see the near-ready projects are also dominant in these areas. So unlocking these areas for the wind projects becomes critical to be able to get wind projects connected into the grid. What we see with type C projects then is that a huge spread of projects moving towards the north, a large amount in the northern part of KZN, and spreading into Mpumalanga in terms of the wind resources, but still some new developments in the historical areas. If we look at the same for PV, this is pure PV projects that are ready. So the dominant is out in the north. If we look at the interest of PV and batteries, you can see that the developers are moving the Northern Cape into batteries, which makes sense to shift this into the area where the grid still has capacity. But they're also recognizing that there will be congestion with coincidence of solar at the same time during the day, and they're developing their projects with batteries in the northwest as well. You'll see very little projects in Limpopo. Even in the near-term projects, if we go to the projects under development, most of the projects in Limpopo really are in the south of Limpopo, with the massive projects really developing in the Free State Northwest an increased interest in the Northern Cape, but all of them with batteries. Even in the congested areas of the Western Cape, we see the interest in batteries coming on. So you can see the dominance, almost 7.5 gigawatts in the Northwest, 6.3 gigawatts in the Northern Cape, then followed by the Western Cape and the Free State, with very small interest in the other areas. If we look at then the type C projects, you'll see the pattern doesn't change very much. Just the concentration within these areas increases. And at this stage, we've got 32 gigawatts of interest. And you can see of that 10 gigawatts, a third is focused in the Northwest, then the Northern Cape, Western Cape, and Free State. So very focused areas. If we add all the plant back on to the system, what you can see is a very clear concentration. You can almost draw a straight line down the escarpment with the wind on below this line and the solar above this line. So almost a very clear demarcation between where the solar and wind projects are coming. We also then asked, what is the appetite for curtailment? Are you in favor or not in favor of curtailment? And the vast majority of participants indicated that they're in favor of curtailment. And if you have a look in the areas of congestion, the Western Cape is a Northern Cape, Free State. These are very favorable areas for curtailment. Where people indicated that they're not in favor of curtailment, we find them dominantly in areas where there's not congestion. So we can understand they don't see the need for curtailment because the networks are not congested at this stage yet. We then asked them what is the percentage curtailment that they would be looking at, and it was the vast majority took about 1 to 5%. Over the wide spread of the area, Western Cape, Northern Cape, Northwest. So all the areas of congestion, very favorable, at least 1 to 5%. There were areas of 6 to 10%, but these were in very particular areas. And this one is largely the gas project that is dominating this. So I wonder, I think if somebody's online, if you wouldn't mind muting. Okay, we then asked them also with the battery projects. There was 99 projects interested in batteries, 25 gigawatts, and about 73 hours. Generally, the battery sizes were about 4 gigawatt hours, dominantly in the Northern Cape, Western Cape, and Northwest. So these were the interest in the areas. The various different colors here represent the capacity of the battery, and these show the energy sizes of the battery. They're very similar because the ratios remain the same, except for this one over here. You can see it's a large capacity with a very small energy capacity. So the volumes are fairly high, but the energy. So you can work through this and have a look at which ones are interested in PV, which ones are interested in wind, what are the volumes. These give the particular substations, the battery size and the battery volume in terms of energy. And so you can interrogate any of these particular areas using the slide. We then asked, what voltage level are you interested to connect to? The vast majority, the colors that you see here, anything that's green or shades of green is on effectively transmission. So the vast majority of parties are interested to connect on the transmission, of which most of them want to connect on greater than 132 kV. So the volumes of the projects are getting larger, and they would like to have high voltage levels, or at least onto the 132 kV network. And there are some that said they would want to connect onto the lower than 132 kV, but most of these areas are in the older the part of the network where there's 88 kV network, and hence they're connecting in those particular areas. We then have a slide here that can have a look in the various GCCA areas. What is the interest in the particular areas, and what is the interest at particular substations? So you could click on any one of these. It would then zoom into the area tell you the density of interest at any particular substation, and give you a particular what is the type of interest that is in the areas. And you can interrogate this to any particular area to have a look at what is the volumes. If you hover over these, it will tell you the actual sizes of projects and the substations that the particular interest are. We then have a map here which gives a very similar view, but it really ranks the projects into what is the maximum interest in a particular area, to look at the concentration and where additional substations are likely to be required to be able to capacitate the interest in the area. So these are available on the Eskom website. We also use these inputs into the TDP, as Leslie indicated, but we also cross-correlate these surveys with the data sets from the EIA's applications and various others to test whether the survey is very relevant. And what we see is that particularly in the near-term projects, they have a very high correlation with the applications. So which is a very positive input, that the developers are taking the survey quite seriously, as they understand we use it in the TDP to look at to fast track and prioritize the network. Thank you.
Thank you very much, Ronald. There've been lots of questions already. To start off, I'd like to just have one of the three presenters perhaps touch on a few items. The first is large power transformers, typically 315 and 500 MVA transformers, cannot be manufactured in South Africa at the moment. And the delay in the manufacture of these transformers is now increased from 12 months to 24 months. Somebody can comment on that. Then the next question, seeing that the grid is so constrained, the transmission lines, why are we not converting present ACSR lines to high temperature, low sag conductors, where we can get another 60% out of the same transmission lines? Or use dynamic line rating?
All right, do you want me to answer that one?
Yes, you can go, Ronald.
Okay, so dynamic line rating or high thermal rating are really provide value for short lines, generally up to about 150 kilometers, because then you would be able to load the lines to the temperatures, and you have a thermal constraint on the line. Most of our lines, they run over 300 to 500 kilometers and extend even further, which means that they're actually constrained by voltage constraints, and they run into they very seldom run anywhere close to the thermal ratings, and they run rather much closer to surge impedance loading, or if we serious compensate them, we can push them to about 50% above the surge impedance loading. So for a 400 kV line, you probably, if you're lucky, get half of the thermal rating. So on the long distance transmission lines, there's not much value in increasing the thermal rating, because we very seldom get to those rating conditions. But in closer to the cities, where the lines are shorter, there is potential to have a look at that. There has been a lot of work to have a look at. The other thing is, because the lines are so long, dynamic line ratings are problematic because of the distance and the different weather conditions to monitor along the line. But one that is very useful is to just remove the solar radiation from the calculations of the line, and that can give you an immediate 20% thermal upgrade. So in areas where you have high densification of wind, that could possibly cause a thermal rating. It's a very useful measure to include those ratings. But at this stage, we're really moving power over 1,000 kilometers, which is really a voltage collapse problem.
If I could take the other question, and maybe Zizo can come in through you, Chair. I think it was related to the transformers, that there's only a single manufacturer in the country. Yes, we are aware of that. I think in Zizo's presentation, she did indicate that we are already pre-approved, if I can put it that way. Additional, Zizo, is it around 20 suppliers or even more?
It's 20 for Class 3B transformers, Leslie.
That's correct, thank
that
you.
we have approved these. And also further to that, we did receive an exemption from DTIC to be able to buy the transformers, especially the 500 MVAs internationally. So those are the strategies that we also have in place. Thank you.
Thanks, Zizo.
Right, let's move to the questions and I'll take them chronologically. Douglas Mweni asked, is there a similar generation development plan with a 5-year window or more? Leslie, perhaps?
Yeah, I thought Ronald would be in a better position because he does the strategic planning. The generation plan for the country is actually comes from the Department of Mineral Resources and Energy in the form of the IRP. And we have to translate that spatially in terms of where the new generations will be located for the various mix of technologies. But if you're referring to a generation plan like exactly what we have done, we haven't, but suffice to say, at the Eskom level, we have a production plan that talks about capacity that's coming through. And we also do the medium-term energy outlook for the country, telling us what new generation capacity will be required to ensure the sustainability of the system. Ronald, if you want to come in there from your side.
Yes, no, that's accurate what you've said.
Yep. So that's why it is crucial that the generation plan for the country plays such a huge role so that we can get the networks. And I think the challenge we face is that the transmission system must be way ahead of the first unit coming online from a specific plant or technology mix in order to get the system up and running. Thank you, Chair.
Thank you, Leslie. Next set of questions also centered around transformers. And the question is, has Eskom booked capacity in these 20 transformer manufacturers for transformers so that we don't join the queue at the back, but we rather already have slots in their production planning?
Lisa?
Thank you, Chair. Yes, so that's part of the exercise that we have been doing with the resource planning in terms of the capacity that is available in the country and also the capacity with the suppliers that are already, we have contracts for example, for transformers. And that's the strategy that we've also deployed to have those 101 transformers out in the market is to mitigate this particular risk that you are mentioning, because some of those projects that are for those transformers, they're still on the developmental stages. Thank you.
The next question by Lundi. Leslie, we don't see many connections to our neighbors. At the moment, there is about 1 gigawatt of capacity in Zambia, but it's nearly impossible to get it to South Africa given the constraints through Zimbabwe and the interlink to Zimbabwe. Why are we not beefing up our connections to our neighbors?
Thank you. If you're specifically referring to surplus capacity in Zambia, but to the only way to get the power from Zambia to South Africa is via Zimbabwe, and I think that network is limited as we speak. But Ronald might come through because we have links with all our neighboring countries to Mozambique, Namibia, Botswana, Zimbabwe. Ronald, I'm not too sure if you're aware of the edition. Yeah, go for it.
Yeah. Well, I think most of the Southern African power pool still remains in a net deficit. They tend to just be breaking normal conditions now, but there's no significant excess that can be exported. And the projects that have been identified to improve the export have not yet got a business case to improve it. So there's been many that have been proposed over the last 10 to 15 years, and we're very well aware of the corridors that are required, but the net difference is challenging to contract it through all the various countries at this stage. The most promising one is still through the corridor with the highest capacities to Mozambique, then to Botswana, and the one in to Namibia is unfortunately constrained by the Northern Cape, and most of the generation in Namibia would be PV as well, or solar, which further congest the network. Yeah. So we know of the projects, but the business cases have not materialized to date.
Thank you, Ronald. There's very little interest in your presentation, looks like, in CSP, concentrated solar power, and you touched on the fact that there's primarily voltage constraints in the Northern Cape, which means that you need to add some form of reactive power, and CSP can make a contribution there instead of putting in capacitor banks or synchronous condensers. So why is there so little interest in CSP in the Northern Cape?
Cost. They're not cost competitive compared to the PV wind and the combination of PV wind and batteries. So in the modeling that they do, and also from the IPPs themselves, there doesn't seem to be interest, mainly because of a price pressures. In terms of the reactive power compensation, and we also get that value out of the batteries, which effectively are very good reactive power sources with high speed response. So and also if we run them in grid forming mode, they also have a very positive effect in supporting the network. Plus, you get the benefit of storing the energy and being able to release it in more discrete periods where you can fit it into where there's capacity. And because they're modular, you can place them along the network where these reactive power, which you can't move over very long distances, across the network. So the batteries play a very useful role in actually enhancing the transmission capacity and supplying reactive support.
But none of the power electronics based equipment makes any contribution to fault level. So isn't fault level going to become a major problem in the Northern Cape?
Yes.
Yes. Okay, good.
Yes. So the first problem with inverters is ability to control the voltage because of poor fault levels in the area. So many people speak of inertia, but that's not really the first problem. The first problems are voltage control and phase jump. So synchronous condensers will be required, and they will be required to assist in fault level, but also assist in controlling the voltage and the phase jump across the grid. So with the inverters, there become various different problems that need to be addressed, and not any one technology really sorts out all the problems. So you really need a combination of these two to be able to improve the network stability or security.
Thank you, Ronald. Through you, Chair. surprising. We were just doing the evaluation. We were out into the market about a month ago for network stability technologies, synchronous condensers or hybrids. We will be out on an RFI, which we're busy finalizing, and then into the future, the studies have been done, as Ronald mentioned, to give us an indication as to where locations on the network and the sizing of these devices. So that will be the next phase of that project. Thank you, Chair.
Thank you. I think, when you look at the cost of PV, for example, you've got to factor in storage and also compensation, for example, synchronous condensers. And I think we leave that out very often and only look at the cost of the PV. And I think then CSP will probably become competitive in the process. Let's move on to some of the more other questions. Dexter Falkvine asks why we're not looking at new coal-fired power stations in Mpumalanga.
If I can come out there, if you look at the IRP 2019, it indicated 750 megawatts by 2023 of thermal power, and followed by another 750 megawatts of thermal by 2027. The one in 23 hasn't materialized, but if it does, if coal comes into the future, chances are it'll be close to the coal belt, which is probably in Mpumalanga or Lephalale. From a network perspective, we have strong transmission networks in these areas. So we don't foresee any major challenges based on the existing strong network. So if a thermal plant is decommissioned to be replaced with a thermal plant, so be it. The networks to a large extent in those areas would suffice. We are looking forward to the new IRP. Hopefully it should come out by the end of this year or early next year from the department, and that will give us a much more a stronger indication as to what the generation mix is. And that choice is left to the Department of Mineral Resources and Energy. Thank you, Chair.
Thank you, Leslie. Bongani asks, why are we still having load shedding in the Western and the Northern Cape, given the fact that there are constraints in the system? So why should they not be load shed?
Okay, I can
Good
respond.
question. Okay, I thought I saw Edgar Capes here from the City of Cape Town. Maybe Edgar will answer, give us a true real life experience, but go for it, Ronald.
Yeah, but can I just clarify the question? Is the question, if there's constraints, why are we not load shedding them, or
why are we load shedding the Western Cape?
Why are we load shedding? Yeah.
Yes.
So the load shedding is a system requirement that ensures frequency control. So if you have an imbalance of generation, or if you have an excess of generation, you schedule the generation to match the load, and if you have an excess of load, you schedule the load to match the generation. So when there's a total system imbalance of too much load, you start scheduling it, and wherever you can schedule it, you will schedule it. Where you can't schedule it, or where you shouldn't schedule it, is if you have a net export out of an area that is reaching the capacity of that net export. In that period, load shedding in a particular area doesn't make sense. And the system operator, even in the current network, looks at these areas and won't load shed an area where there is excess power going out, because if you have to shed that area, you actually lose the export of power as well. So the point where there would be no load shedding in a particular area is when the net export in those areas are greater, or continuously exporting out, and then load shedding in areas doesn't make sense. So that's when load shedding in a particular area for the system constraint would not make sense, because you'd actually be reducing the generation output in that area, and it's actually counterproductive to system balancing.
Thank you, Ronald. There's been some questions also about where's the money going to come from, and just today there's been a news article saying that the US awards Eskom millions to help expand the grid. So where is all this money going to come from to build 1,600 kilometers of 407.65 kV lines in the next 10 years?
I think I'll take
You
that
want to
one.
take that? Okay, thanks.
Yeah, I think in the I indicated in my presentation, at least for the coming 3 to 5 year window horizon, we managed to secure the necessary capital. Yes, there is a challenge with the announcement from Treasury in terms of that relief package, that Eskom cannot take on any further debt. So yes, there will be a challenge post the 5-year horizon, and we are working closely with our principals in order of how to resolve. I think we need to be clear. There are willing funders, if I can put it that way. Our problem is not getting funders to fund our projects. Our challenge is the balance sheet does not allow us to borrow additional capital to pay off any additional debt that we incur. So the challenge going forward through our corporate finance and with National Treasury is to see how we can resolve that in the coming 2 to 3 years' time. Suffice to say, at least in the 5-year period, for the projects that we've got on the go from the TDP, we've managed to secure the necessary finance for that. Thank you, Chair.
If I may just add, I also would like just to put in perspective, because the numbers are often big numbers, and they look bigger than what they are. So the 10-year plan for the TDP runs just over 200 billion. But to put that in context, one bid window runs above 300 billion. So the total TDP costs are less than one bid window's cost. And so the ratio of the transmission costs are less than 10% of the ratio of the system's energy and capacity cost, and relatively a very small amount. And it unlocks then a more competitive market where you can get a much cheaper price on the 90% of the cost of the system.
Thank you, Ronald. Nothing has been said about pump storage and project at Steelpoort, for example. Why aren't we hearing anything about Steelpoort?
Okay, if I can take that. We are working closely with our colleagues in the project development space on the pump storage scheme. Unfortunately, that because of the dams and the civil complexities, that type of project will take a fair amount of time. It'll probably just go outside the TDP. Having said that, we have done the studies. So I think you mentioned Tubatsi, which is in the Steelport area some time ago. So from a network perspective, and if you look at the detailed plans that we have in the Steelport area, which is on the detailed TDP presentation, the plans that we have put in place is quite adequate to deal with the pump storage scheme of, I stand to be corrected now, but I think it's between 1,500 and 2 gigawatts coming out of that area. So we have the network plans for pump storage. It's a matter of the timing. Sure. Thank you.
Thank you, Leslie. A question about the energy mix, perhaps towards Ronald. Is there any constraints or in terms of the energy mix that is being proposed in terms of renewable energy?
Yes, so the generally the mix needs to be looked at in terms of the instantaneous penetration when you look at the grid rather than the total or the energy component of it. So for example, at the moment we've got a relatively small amount of renewable energy. But if you look at already the instantaneous penetration is above 20%. So what you have to be careful of is that once you hit penetrations above 30%, it's really not a super problem. After 30%, you need to start looking at then augmenting the system to stabilize the system to make sure that the inverters actually operate correctly. And once you start hitting above 65%, you really have to start improving the inverters themselves. So the system becomes a lot more weaker. You get a lot more excursions on the grid, and the inverters themselves specifications need to improve. And also you need to start introducing grid forming technologies in particularly weak areas. And once you get to penetrations of 80 to 90%, these instantaneous penetrations are not really at a stage where they can the technology is fully developed at those stages. So there's still ambitions to run the system. There are many areas where people say, yeah, our system runs at 100%, but it's not the entire system. It's just some portion of the system. So I would say after about the 80% level, there's still a lot of work to be done to prove that the system can remain stable and augmented in. But there's a lot you can do up to those points. You can use curtailment to limit the total penetration and still get significant amount of energy contributions to it without having these very high instantaneous penetrations. So there are many ways that you can look at it to harvest the energy without reaching these high penetration levels. But yes, it does become problematic with very high levels of penetration.
Ronald, when do you see in the future that we'll have an oversupply of PV in the middle of the day? And what will happen then? Yeah.
Well, I mean, the first key thing, I mean, is to speak to what you mentioned earlier as well, is that you need to have an appropriate tariff to properly respond or send signals to the market under these conditions. And at the moment, we've got a single volumetric tariff, which means that you effectively add in the capacity and the energy together, and you're saying that this is an equivalent tariff, which is a very inappropriate and archaic way of designing a tariff. And the main reason is that you've got batteries and gas and so forth, which are a capacity. They're not an energy source. And then you have energy sources, which are energy sources. And you need to separate these tariff signals to better indicate what the value of these different areas are. So you need to have signals that also encourage the load then as the penetration of solar PV is generated in the area, to signal that and encourage load to move into those areas. And an example now is that, for example, if you're in the Northern Cape, you're actually penalized for putting load in the Northern Cape, and you penalize further for putting load during the daytime, which is exactly where we want our load and exactly when we want our load. So when you get to these higher penetrations, the signaling of your tariff becomes really key to change behaviors and to better optimize the coincidence of the load as well as the generation together. And of course, storage is key, particularly for solar, to be able to clip and move it out into more profitable areas or more valuable areas. And I think those are the mechanisms that are not yet there and need to rapidly be put in place.
Thank you, Ronald. Another question, when do you think the transmission system authority would start taking control of inverters to, for example, help in grid forming or in the injection of reactive power? And do you foresee something like that to happen in the near future?
Yeah, so if I can come through. Yes, I think the studies indicate by depending on the rate of or the penetration level, and with our current projections, I think we're looking at around 27 or thereabout. that we're going to need those devices onto the system. And as I indicated earlier on, we are in the process of evaluating such technologies. And within the coming months or so, we'll be in a better position to go out to market. Actually, I think, Ronald, you did the study, if I'm not mistaken, on for the synchronous condensers.
Yes.
Yeah, and I think it was around 27, if I recall correctly, based
Yes,
on our current assumptions.
That's right.
Yeah.
Thank you. There's a question from Dave Nichols, and he said that the current cost of lithium-ion batteries, 80% of that is now input cost from materials, so the cost of batteries are now rising. How is that going to affect the installation of batteries on a large scale in the Northern Cape?
Yeah. Go for it, Leslie.
Yeah. That question also came up during the course of the week or last week, Ronald. We'll be in a much better position because the IPP office by the DINRA have gone out on a procurement program for battery energy storage systems. I stand to be corrected. I think it's about 560 megawatts. And then Eskom has also got its program, the BESS battery energy storage program. We'll be in a much better position in the coming months once we see what the prices come through to answer that question. I was of the opinion that the prices are coming down on a global scale, but as I said, we'll get the true cost in a couple of months' time. Ronald, I'm not too sure if you've got any info on the costing.
Yes. Yes. I mean, I think the first thing is that from the transmission side, we don't specify what generation comes or what are the economics about which generation should be where or what. These are run through economic models to have a look at what is the most resilient or combination of mix of plant, and in those studies, they run the latest technology values when they calculate it, and that indicates it. So if the price rises, they would include that in the models, and it would then shift out those particular battery sources, because there's many other types of storage that is available, not just the lithium ones, and also it might then favor other forms of storage like the pump storage and so forth, and bring them forward. So we really need the economic dispatch models to be run with the latest prices to give us those answers, but we don't run those studies.
Thank you. Perhaps another question about costs. In South Africa, the cost of PV is now down to about 60 cents a kilowatt hour. People think that is low, but very recently, a project in Dubai, the cost is now down to 30 SA cents per kilowatt hour. Do you think the cost in South Africa will drop to that extent?
I think it's very difficult to compare. Different countries have different cost structures, subsidies, tax incentives, etc., etc. So you need to be very careful when you look at these numbers on what is behind the numbers. So those you can see even in the previous bid windows, there was what they call the race to the bottom, where the prices are not really sustainable. So you need to be very careful comparing those prices if you don't have a good indication what are the cross subsidies or behind them. But those prices look they look like they've been subsidized.
A question about what IPPs are willing to pay for access to the grid in Australia now. They're proposing that IPPs pay a premium to get access to the grid. And here's another question in the same frame. Aren't we going to soon start asking IPPs to also make a contribution to the transmission development?
If I may comment, everybody makes a contribution to the transmission development if you use the system. So the system use of service charge allocates the cost of the transmission to the users of transmission. And each user, if you're a generator or load, at that point of connection, the costs are apportioned to the use of the assets. And you're paying then at that point for the use of the assets that you have. So the problem that currently exists is that the current historical tariffs are really not appropriate, because you'll see they again penalize people in the Northern Cape, for example, for the distance away from the coal centres. And secondly, where it becomes problematic is historically the tariffs were calculated because the most historical use of the grid was at time of system peak. So it was in a particular hour when you calculate the use of system charge, which made sense in that particular era. But with solar, wind, etc., the use of the system changes to different hours of the day. So you have to change the tariff structure to calculate the use of system charge in a different way. And then you still get a nodal or zonal pricing, and that means that everybody still pays the services at the point for the entire transmission grid. And that's really the changes, is that everybody still pays, but you need to refine it to better allocate those costs because of the new change in technologies.
Ronald, if I might just add, the costing structure is actually governed by the NERSA, the regulator, in the tariff code. So it's not that transmission sets the cost, it's governed by regulation from the regulator. But as Ronald mentioned, the methodology has to be relooked because the methodology served the purpose in the past. And now we have a changing dynamic going forward.
Gerda, we've now been busy for nearly 2 hours. Do you think we should stop?
Well, we can take it up to 8 o'clock.
Okay, that leaves us with about 4 minutes. Somebody that'd like to ask a question verbally, if you can put up your hand. Dave Nichols.
Thank you, Professor. Just a very quick question. Sorry, I'm in the middle of load shedding. The IRP 2016 and then 2019 made an assumption that the cost of integration into the grid was similar for most technologies. We've now got a situation where we're seeing a number which is based upon the need to reconfigure our grid for the new system away from dispatchable plant towards intermittent plant. Do you believe that, well, basically, is this number now being included in the current IRP work being done? You must have an input into the IRP work to say that we must include this cost into the cost of the options. And I asked that because I know when I was running a nuclear project in Eskom, the cost of integration to the grid, including substations, was charged to the project in the overall costing. So I think that's I don't know who would answer that question. Thank you.
Yes, I can respond. So no charge is charged to the project, even the nuclear projects. What it is in the Eskom context, so it may have been evaluated with the project, but it's not charged to the project. Each generator would still be charged a use of system charge, which takes into account the NERSA tariff methodology. So when you look at the IRP, the past one, it was not an assumption that the different generators would cost the same amount. It was a simulation that they cost the same amount. And the reason is that the load centers, whether you use whether you use nuclear, you'd still need to move the power from the nuclear, if they're on the coastal areas, from the south to the north. And if you're using renewables, you'd still need to move the power from the south to the north. So if the volumes remain the same, the sizes would remain the same. The main difference with the renewables is they dispersed over a wider area. So you have a slight difference in cost to harvest them from different areas, but the actual transmission cost remains very, very similar for almost any scenario, whether it's nuclear, coal, or renewables. Where the IRP 16 and 19 said the biggest difference comes is that the difference is not the transmission cost, but rather the distribution cost, because the nuclear plant or conventional plant, nuclear, coal, gas, connects directly onto the transmission bus, where the renewable plant needs to be collected somewhere where they're generating, brought on via distribution networks, and then transformed from the distribution voltage onto the transmission grid, which is not the case for the conventional plant. So for transmission, the costs are very similar across any scenario, but the distribution costs can significantly differ. And that was the statement that was put in the IRP 2019.
Thank you, Ronald. I think this is a good time to end our discussion. Thank you very much to everybody that has joined. I see we peaked at about 177 people this evening, so showing that it is a very topical discussion that we've had. If you have any suggestions for additional topics that we can cover in this way, please send an email to Gerda at the Institute. You can find her email address on the Institute's website. And then with that, I'd like to thank our three presenters, Leslie, Zuzu, and Ronald. Thank you for a very detailed presentation. There have been questions about the presentations. Ronald has shown where you can find the Eskom presentations. We'll also convert this Teams meeting into a YouTube video, and that will then shortly be posted on the SAIEE TV channel on YouTube. So with that, thank you very much, and we hope to see all of you shortly, and goodbye.
Thank you, Chair.
Thank you, Chair. Bye, colleagues.
Bye.
Bye.